Hi and welcome to Cherry Pie Math. This video is going to be introducing the idea of linear slope. Before we get started, there are a few things you should know. First, you should know what the definition of a mathematical proportion is, especially to know if things are proportional. And if you're not sure, I just made a video about it that you can check out. You should know what a unit rate is, or at least be familiar, like you've heard the word before. We are going to be talking about that a little bit more in this video. We aren't going to concentrate on it super hard, but you should be familiar with a unit rate. And you should know what an independent variable is versus a dependent variable, because those are very important and they will help you keep track of the mathematical ways to write slope. So to start out, we have these three triangles here, and we can just see right away, just by looking at them, that they are obviously similar to each other. And I mean that in a mathematical sense, where they're proportional to each other. And so I want you to think about, how can we tell that they're similar even though we don't have any numbers? How can we just tell by looking at them that they are similar to each other? Okay, so if you paused the video and you thought about it, you probably thought about how they are the same shape. Like if I changed it to like an equilateral triangle, obviously it's still a triangle, but it is not the same shape. And a more mathematical way of saying the same shape is that they have all the same angles. And that's actually a triangle requirement for similarity, is angle, angle, angle. So all of these have the same three angles, and that's kind of what maintains that same shape. Because if you change any of those angles, all of a sudden one side is longer, etc. And another reason we can kind of think about it is by looking at the hypotenuse. And the hypotenuse, which is the longest side here, you can tell it has like the same steepness. So if I was like a skier, here's me skiing. I hate skiing, actually. I have so many bad stories about it. But it would be the same slope for all of them. Yes, some of them are longer, but the slope is the same for all of them. And that's where the idea of slope comes from. And no matter where you are on a line, that slope is going to be the same. So let's talk about what is slope exactly. Slope is another word for, so we could also call it the rate of change, or we could call it the unit rate. And basically all it does is it represents how steep a line is. So like I was saying with the skier example, that steepness would be my slope, right? And we kind of use that word in everyday English anyway. This is just going to be talking about a mathematical way to represent that, so we can show that on a graph. So slope is the same throughout the graph, regardless of what 2 points we're looking at, because the slope never changes along a line. So if I have a line here, like we had in the triangle example, if I take a point here and a point here, there's a triangle, but that has the same slope as if I take like a little tiny baby triangle, and that slope stays exactly the same. And we can visually see slope in a graph if we imagine that right triangle, like I just showed. It also helps us determine what the rise is, and these are important words. Rise, that means how far we went up on the y-axis, because y is the vertical axis. And it also tells us the run, how far we went right on the x-axis. Those are very important words. I want you to memorize them, rise and run, because slope is really just rise over run. So again, looking at the triangle examples, if you look at these triangles, you can kind of see that that third one there isn't quite the same shape. Like, yes, it is a right triangle, but the steepness is different. It's a little bit more steep than the other two. So we can tell that these two triangles have the same slope because they have the same angles and hence the same slope. Whereas that third one has different angles and different slope, and so it wouldn't be considered the same slope. And I know I keep using that word slope a lot. It's kind of cool to me that they have the same meaning mathematically in English, because sometimes they are different. But the nice thing about math is we're going to quantify it. We're going to write down a number that will represent how steep something is. So on a graph, the slope on a graph, if I was to quantify it, kind of like if I was to measure how big something is, I would use like a ruler. Slope on a graph is the rise, there's that word again, over the run. And the rise is your increase or your decrease in y. And your run is your increase or your decrease in x. If you mix up your x and y axis, it's going to totally change your slope. Please make sure that you know that the y axis goes this way and that the x axis goes this way. If you mess those up, you are not going to do very well. So just make sure you keep those straight. Okay, slope is the same on the entire line, like we said before. And like we said before, slope is the same as the unit rate. And just a quick reminder, unit rate represents how much something changes in the space on one variable when the other variable changes only one. So if I was to buy like pounds of potatoes, my independent variable would be pounds of potatoes. So for every 1 pound, it costs, I don't know, $2, right? That would be my unit rate. So it represents how fast something is changing. That's what the slope does, is it tells us what's the slope of a potato graph of $2 would be much different than the slope of a car, which travels, 70 miles in 1 hour. This is also why we call it the rate of change. And you'll hear that more in high school math, just because we want to talk about how fast something changes, right? But the big idea here is slope is rise over run. Memorize that. Keep it in your hearts. Never forget it. You'll be tested on it on the ACT. It's super important. So now that we've determined what the definition of slope is, that it's rise over run, let's talk about how we can figure out what that slope is based off of a graph, if I have a graph. So here I have some examples of graphs, and we can see that one of them has a much steeper line. This is much steeper, because if I was trying to climb it, here's me. It's hard to walk up. But this one is really, it's like a lower slope, and it's kind of an easy walk down. I don't know. It's kind of fun to draw the people so that you can see how the slope works. And we always read graphs left to right. Do not forget that either. Okay, so if I have a graph, we know that the graph, or the slope on the graph, is really just the unit rate, which is the same as the slope, which is our big word for today, which is equal to rise over run, which I've said like 6 times, and I'm going to say it more again. So if I have a triangle like this, for example, or like I'll do a downwards ones too, because like I said, we always read graphs left to right. So this is actually headed upwards. This is headed downwards. The rise is the vertical part here. So from like here to here, that would be my rise. Whereas, let's do, I don't know, we'll do pink. My run would be the vertical part here. So we're just really telling how much it rises and how much it runs. If I have an equation, and we're not going to be talking about lines that are anywhere else except for the origin right now, but this number in front of x is actually the slope. So that's how you would tell what the unit rate is. It's just that number in front of x. So if I look at this graph over here, I can kind of see, like, let's do the blue one first. I'm just going to draw a nice triangle. So I'm going to find a nice point. Here's a nice point here. And I draw a right triangle. Whee! I can see that my rise, oh my gosh, that was so terrible. My rise is this part here. It's the vertical part. And that is +1, we'll say. Actually, no, it's -1. We're going downwards. My bad. So we're headed downwards. From here to get to this part here, we're going to -1. We're going downwards. And then we do go to the right. Right is considered the positive direction, so that would be +5. And if I was to write that out, it would come out to be this equation here, because the top represents my rise and the bottom represents my run. If I was to do it for the red one, I'll do it up here. So here's my right triangle. To get from this starter point, I go up 2, so that's +2, and I go right 1, and that's +2 over +1. That's my rise over my run. Again, 2 over 1 is really just 2. That matches to that equation. So you can kind of see how drawing those right triangles help us to find what the rise and the run is on the graph, and helps us to match it to the equation. Direction matters a lot though, and especially when we're writing equations versus drawing the graph. One thing I saw students do is they would remember it was rise over run, but then they wouldn't keep track of what was positive, what was negative, that we read graphs left to right, and it would just mess up the direction of the slope. So please, please, please remember that you read graphs left to right, and that positive and negative matters. Seriously, guys. Do not forget those, or it's going to screw up your entire graph. So if I was to write an equation, remember we said that it was y equals mx, where m is equal to the rise over the run. That's my slope. So if I wanted to draw a line, if I had that slope, if I had the equation and I wanted to draw it, and I had y equals mx, where again, m is rise over run, and I swear I'm just going to write this over and over until it like drills into your brain. You would start at the origin in this case, because we're not dealing with any y-intercepts yet. I'm going to make that in the next video. But you would start at the origin, and then you would rise whatever the numerator is. And then you would run the denominator. So the top is the y, the bottom is the x. If m is a whole number, then really it's just, because any whole number you can just put over 1. So you do like the number over 1, and then you know that your run is just one space, which is kind of nice. I have this chart here, and it's going to help you determine like if it's positive, if it's negative, what direction that's going. So let's say this is positive y, this is negative y, this is positive x, this is negative x. Okay, actually let's do that in blue because I can. Okay, so if it's positive y, I'm going to be heading upwards. Okay, no matter what. Positive y goes upwards, negative y goes downwards, obviously. Positive x goes to the right in both cases. And then negative x would go to the left. And I do have them in different places just because it'll be easier to kind of see like, oh, this line goes like this. This line goes like this, because you start here and you go like that. Once you draw those right triangles, it'll just kind of help you know where to go. So write that down, keep that handy. It'll become supernatural after you do it a couple of times, but it'll just be helpful for the first little bit here. All right, that was a lot of talk, so let's try it. Let's see if we can figure it out. So we have y equals negative 1/2 x, so that means my slope is negative 1/2. When a number is negative, you have a fraction with it, the negative actually can go with the top or the bottom, but only one of them. The other one is going to be positive. So let's start with the scenario where y is going to be negative 1 and x is going to be 2, or like your rise, I guess. Let me write that instead. So your rise or your y and your run or your x, okay? So that means if I was to start at 0, 0, I'm going to be heading downwards one space, and I'm going to be heading downwards or heading right 2 spaces. So start at 0, 0, I go down 1, and then I go 1, 2, and that's going to be my next one. And I can actually just keep repeating it. So if I go down another space and go right 2 spaces, I have another one here. And you can see that my line is starting to be beautiful. And I could actually go the other way, and that would be totally fine. If I wanted to do my rise or my y as the positive one and my x as negative 2, then I would be going up 1 and I would be going left 2. Okay, so if I start here again, I go up 1 and I go left 2. But notice it's actually just the same line, right? I didn't, well, if I can match them up, there you go. It's pretty much the same. It's all just that same line there. It has the same slope because that negative can only go to one spot. So that was just kind of a visual example. Once you get used to this, all of this, you don't even have to write it down. Like I look at this and I'm like, oh, I usually do y as negative. That just is how my brain works. I'm like, okay, I start here, I go down one and I go right two. And then I just draw my next point. But just for now, while you're getting started, use this chart here to help you, and then start at 0, 0 for now as well. So some things to remember. The slope is the same as the unit rate, where x is the independent variable. I didn't really talk about that a lot in the video, but x is always your independent variable. It's just a standard thing throughout mathematics. So your x-axis is always going to represent your independent variable. And remember, rise over run. I cannot stress that enough. We always do change in y over change in x. Y always goes on top, x always goes on the bottom. Slope is the same on the entire line. So if you have a right triangle, all the triangles will be similar, no matter where you have your 2 points. Okay, I hope that helps you at least start to understand a little bit more about slope, how to apply it. In my next video, I'm going to be talking about what to do if it doesn't start at 0, 0, but the idea of the slope stays the same. If you have any questions, drop them in the comments.